Right. So today let's continue with our project stacklang, and we'll have a small intermission on trying to get environment variables into the language and also command line arguments. And I was yesterday playing around with GDB, and what I've noticed, let's just recompile everything. So I was able to add all the tokens for the language into stack.sl. So now the tokenizer is complete, and I was playing around with with GDB, right? And I was running it on main, right? And then I decided what would happen if we put a breakpoint at start. Let me just zoom out a bit. And then we try to run and give it stack.sl and -a the arguments, right? What would happen? And what I've noticed is that initially the stack is going to contain the argc, the argv, and then I guess this is the environment pointer, so all the environment variables. So yeah, and rsp contains the pointer to argc. So I was thinking, what if today we try to get argc and argv into our main programs? Although it's a bit maybe inconvenient, because this will force us to always have something like this, and sometimes, you know, I like to not have to put the arguments into main, so not sure. Although since they are the first items on the stack, we can ignore them, right? So that's a good point. So yeah, that's the idea here. So let's actually try to have these things into cool, right? Because into stack, but the cool compiler was talking about me, I guess. Anyway, so what I see, it's the RSP pointer or RSP register that contains a pointer to the stack. Initially, obviously, it's containing the pointer to the stack, but the stack has argc and argv. So let's try to add argc and argv to the language. Then maybe I'm not sure how this thing is called in C. I think it's like args or something. Anyway, yeah. So that would be the goal for today, because as I said, the tokenizer is complete, and we have a checker. So nix run checker, but the checker only runs the C code, because and if we go to checker, or I guess nix flake, whatever, the checker will execute the main program with the arguments, the file, and I mean, these are the command line arguments, so it's already let's say over for our little body. So yeah, let's go to main.c. So this is where we need to do some stuff so that we get this this RSP pointer into some kind of variable, right? So it's gonna be assembly programming, but in C. So we'll get the RSP first. We are gonna store it somewhere, and when we call the main function, we are gonna push some variables. So let's see. I guess when we emit the entry point, right? When we emit the entry point here, we call the main function. So my idea is that if we let's just put some comments or something. If we push some garbage on the stack here, and the main function doesn't have those types as the inputs, then that garbage is ignored, at type checking at least, right? And when we pop at the end, because we are in a last in first out environment, this garbage is gonna also be ignored. So that means, interesting, it's only gonna work. I'm just thinking, let's try to just do argc and argv, right? And I'm not sure how we're gonna do environment variables. Maybe it's gonna be something else if we are gonna need environment. I mean, we need environment variables, right? Because we have that stack home thing. Maybe it's gonna be something different for environment variables. So what are we gonna do in this place? Right. Well, we need RSP. We need to store RSP. So easiest thing would be to let's add some space. So, and let's do like a plan. So we need to read int from RSP into basically argc, and then we need to store RSP into a PTR, right? Or at least say that the RSP is a PTR at that stage. So it's already allocated, we don't need to worry about it. It doesn't sound that complicated, to be honest. So let's see what these steps are gonna be. And I mean, I'm pretty sure it's gonna take 5 minutes, so yeah. So let's do something like, we have a function push, or it's stack push, right? Stack push, and this function is allocating something on the heap and then pushing the pushing RDI in that location and storing RDI, or I guess the result of allocate, on the stack. So if we call stack push, right, and as I said, stack push has the input in RDI. What if we move? So this should be call stack push. Let me just tap this a little. Right, we call stack push. And what if we move into RDI keyword from RSP? So this should be in fact the store argc on the stack, right? We store argc on the stack, and the next thing we need to do is to store argv on the stack. Now I know we have arrays and cool data structures, but I think we are gonna keep argc and argv as argc is gonna be an int and argv is gonna be a pointer to pointers. Right, so we'll be able to convert them into arrays with some kind of parsing function. I don't know. Yeah, so we'll see. So store argv on the stack. Perfect. So let's first test our theory. So we need to move into RDI RSP, and besides stack push, I have another function, stack push address, which doesn't allocate anything and just pushes RDI as a pointer. So if we do stack push address, we now push RSP as the pointer itself, but we need to do something first, and that's adding 8 to RDI, because RSP points to argc, right? So we need to shift it by 8 to the next next thing. So here, and as you can see, the first argument is always gonna be the executable name. That's nice. And then we are gonna have the first argument and the second one. So let's see what we can do about this, or at least let's see if it works, right? Let's see if it works. So let's go to some, well, I would say let's make, right? And I'm pretty sure that if we run this, it's still gonna work because we don't care about these, right? We don't care about the argc and argv yet. But if we go, I don't know, to hello world, my favorite example, and we add int and ptr, and that, as I said, you cannot have int without ptr. That's kind of I'd like for you to be able to have only argc. Maybe you want to do something with argc, but I don't know. So argc and argv. What if we pop then int show, let's put a new line and string concat and string std out. So let's do examples 0 1 dash a, and we run this thing. So we get 1 because it's only one argument is the name of the program. But what if we have something like hello 1? Oh, I'm I need to put that here, right? We get 3 arguments. Let me just check. Okay, I didn't destroy anything. I didn't nuke anything. So yeah, we get the number of arguments, which is pretty cool. Maybe let's do something like 05 args.sl. Let's import stdlib. I'm also planning to make stdlib. You don't have to import it. So you see we have some functions like or I guess data structures like int, pointer. If you don't import the standard library, you don't have it, you don't have them. So I'm planning to make them like you don't have to import the stdlib. They are gonna live in the compiler itself somehow, but I'm not sure how to do that in a nice way. So yeah. So at this stage we have argc and argv. I want to echo the argvs. So yeah, and maybe we'll figure out a function that converts let's say this thing, this int pointer into some kind of array. That would be nice. So argc and argv, or it automatically generates you a parser, something like that, I don't know. So first I would swap, so we get argc, argv and argc. We don't even need to do that. We'll need a function argsdump, and it's going to take int pointer int. So we have argc, argv, and the iterator. So we can do something like args dump. Maybe doesn't return anything, and then 0 for the output. So we are gonna, I'm gonna keep the stack at the top. So we have argc, argv I. So we want to rotate this thing maybe do a dup 2, right? We check if it's smaller, but we can also do if it's greater or equal then we have to stop the iteration. So this is the base case, and we can just pop 3, right? And in here we have argv I arg c, and on this thing we want to stop. All right, so we are in the else, right? We are basically doing the iteration now. Man, would be nice to get to have while loops, but we are still quite far from that. But maybe it's gonna happen at some point. So what can we do at this stage? So we know argv is a pointer of characters. At least we have that. It's a pointer of characters, or like it's pointer to pointer of bytes, right? It's not pointer of strings. You have to remember that it's pointer of pointers because it's a C style string. Okay, so what I'm gonna do is do a rot prime. So we move argc back because we don't need it anymore. We need it only for the comparison, right? Then, well, it's a rot prime, so it should look like this, right? I would do a dup 2 again, so we get argv and I, right? Then I is just an index, so we have to multiply it with the item size offset or item size, right? And item size is a pointer, as I said, right? That's what our items from this array are, pointers. So we have to multiply I with that, so it's multiplied with size, and now we can offset the pointer. So we just add to our pointer this thing, right? And if we dereference this stuff, so if we do pointer dot star to dereference it, it's like accessing the thing. And yeah, here we get another pointer. So this is gonna be a pointer that represents the value of the argument. So yeah, here would be nice to have some kind of str string length function, right? And yeah, let's maybe think of how string length is gonna work. So string length probably is gonna be like a pointer function, right? Just to have some kind of so it's gonna take a pointer and it's gonna return an integer, right? And the idea is this pointer needs to be null terminated, otherwise this thing doesn't work. I think in C is the same thing. If you run this thing on a yeah, probably it's not gonna work. So then what do we need to do? And something like a small trick I learned is usually when you have a return in a recursive function, it's much better to put also the result into the inputs, right? That's such a good idea. So if we'll have a secondary helper function that does exactly that, right? It takes pointer and the result, right? So here when we call that, we are gonna say string length prime. So this is gonna call our helper function, and the helper function is gonna be a while loop basically. So what do we have to do? First we swap, so we get the result and the pointer, or this is like the length and the pointer. Then we have to dup, so we get pointer twice. Now I would dereference 1 byte from from the string, I wanted to say, but we cannot really do that. So if we take a look at stdlib and we go to the byte section, yeah, I was going insane here. I just put all the, I mean, almost all the ASCII characters. So byte init takes a pointer to a char star and gives us a byte, which, I mean, it's an integer, but you get the point. So let's actually run byte init then, right? If we do byte init, we are going to convert this thing into a byte, right? Now we need to do something like if this thing is equal to byte null, so 0, this thing is equal to byte null, we remove that and we have len and ptr on the stack, right? So here we just pop because we want the integer result, so we want the length, right? We don't care about the pointer, right? And on this side we have to swap one, well, it's a one pointer plus because we want to increment both the length and the pointer, right? So then we swap and then we do a 1 plus, so we have length plus 1, and then we can just recursively call to string length prime, which returns an integer. So why do we do plus 1 and plus 1? Well, because we need to advance the pointer to the next character, and the length to, you know, length is greater by 1 if we find a normal character. So that's string length, right? So at this point, as I said, I kind of want to duplicate this ptr, maybe call pointer.string length, so we get the length of that pointer. We can swap and we can just call string.init, and this way we get a string. I mean, we can do a rv I string, right? So next step, I guess, would be to do string.std out, but maybe I want to put a new line or something, string.concat and then string std out. So we just remove the string from our stack, and as you can see, we just recursively call args dump, which removes everything. So this should be the args, 05 args. Okay, I mean, expected, what can I say? We expected to get a segmentation fault. Damn it. Can I just dupe int.show and then have the same thing like here? So this doesn't change the stack, but we just do some debugging. So we get a 3. Huh, something's not right. Oh, I'm I forgot about the swap. So now at least it's 0. Damn it, do I need to do this thing again? Because I think I need to do it again. So argc. If I swap, we get I. Then I do a rot prime, so we move I back. Oh yeah, I mean it's not needed. So it was fine. So we push this thing back, I said. I mean, I'm not sure what happened there. Maybe it's something wrong in string length. Let's see. So here we have pointer and result. What if we do something like swap and then we swap at the end? What if we dupe our pointer, put something like 10 or I don't know, like 1 swap string.init, and then we doesn't work. What? Pointer size of, really? It's a bit confusing why it's not working, but I mean I would just GDB this thing. Yeah, I mean it's pretty weird. It's also giving me a pointer. Well, oh shit. You know what? This thing should be pushed on the stack, not push address. Oh, so maybe I was wrong here when I said we need to push address. I think we need to just push. And that's an oopsie doopsie. Yeah, that was an oopsie doopsie. God damn it. So yeah, the reason is I just realized that I said we need a pointer, right? But if we push address, we only get a pointer, only one box, because we don't rebox it back. So yeah, my bad, but it is what it is, right? So at least we found the bug, and it was basically here. We needed to just do stack push. So yeah, kind of painful to debug, but at least we got it right, and now we can see that we get the arguments like this, and also the name of the program, obviously. So yeah, at least we have this example, right? Maybe we can figure out a way of generating some kind of list here from this, so we can build some kind of argument parser data structure. I'm not sure, but that would be pretty nice for our compiler. So yeah, let's see. So yeah, we can try to build a parser for our own thing, right? And it's gonna be hard coded kind of for our purposes, because here you can see I have this ds.h parser, like a pretty complex one, but we cannot re-implement this one from C. It's like too hard, I would say. So what I'm actually gonna do is try to have this kind of data structure in here, right? So we are gonna have data stack args, let's call it stack args, and it should have a string file name, right? String file name, and a boolean lexer. So if we want to stop at the lexer stage, which I mean we anyways do because we don't have more than just the lexer, but this is going to be our data structure. So now we want some kind of function args, or it's going to be stack args parse in ptr, and it's going to return stack args. Right, so argc and argv. Right, so what are we gonna do with this one? Well, we need to check. Anyway, like the first thing would be to also know that we need to start from index 1 with our parsing, because yeah, the first argument is just the file, just the program name, so we don't really care about the program name. So we might have a helper function, stack args parse prime int pointer int stack args in argc argv I. Right. So how can we and because if I add something to argv, then it's gonna be stored like that. Yeah, I mean, if I think about it, pointer offset, pointers plus pointer offset, it's I mean, a bit different. I don't know. So yeah, like I here doesn't really help me. And again, I can have the stack args here as both the input and the output. As I said, it's like if you have an iteration that does something, you have to put the input as well here, because otherwise it's gonna suck. So that's a good point. I'm gonna do stack args, right? And these are gonna be the args. So what do we need to do here? Well, we could have the help menu, right? If you get the dash help, that's always useful. So we could have something like function stack args.usage. Right, and it's a function that doesn't do anything. Well, I mean, it does, because it's gonna abort, right? So it's gonna do something like probably if we go to main, where is the parser? It's gonna be something like stack length compiler, right? So stack stack length compile. I mean, I'm not sure if I do main help, how is it gonna print it? It's like usage. Probably I'm gonna call it like SLC, and then it's like options and input. From what I can see, \m string.stdio. Then it's the description, so stack length compiler out. And we have a list of options. And whatever, we don't really care that much about the options right now. Let's just focus on this part. So I would do something similar to this. All right, so while we can do some stuff, oh, and obviously I would do something like sys.exit at the end, right? So probably it's something like rot will not really work. We should do something like swap rot4. Oh, rot4, and then we dupe. So we get argv, args I and argc. If it's too big, we have to pop, swap pop. Right, because we want to keep only the args as the return. So here we do args. Okay, but if we are on the else case, what do we want to do is, so we have still argv, args I and argc. Right, we want to convert argv into a ptr, so it makes sense to do a rot4. Let me bring it forward. argv, we dupe ptr star pointer string and swap and then string.init. So this is like an algorithm for converting a pointer into a string. Right, so now we have also the string here. So we have args I, argc, argv string. Right, now it's gonna be interesting because we lost access to args basically. Which is kind of not ideal. Which isn't really ideal. I mean, we could change to use an array. And then it's a bit easier. So we could initialize the array with capacity, count, size, and items. It makes sense, right? It makes sense. And then we could have an array here instead of this thing. And we can call it array. So how is this thing gonna work then? It's gonna be different here, obviously, but we still have to swap and do all of that. So it's gonna change to args right? It's gonna change to args, and here is gonna be the array, right? Because we swapped these two, then we pushed the array forward, dup2, and then we have to say like array dot count, though array dot count, and if it's too big, then we just pop 2. That's better, I think. Okay, anyway, so at this point we have the args, I, and array. So here would be cool to swap and then dup2. So we imagine we have the array and I. Then we definitely have like array dot get, and we get pointer and boolean. So not if panic v, just to get rid of the boolean. And here we have a pointer, and what that pointer is, it's a pointer to the value, so we have to dereference it once, and now we get the rv that we originally had, right? Because here what we are gonna do, we have the int and the pointer, so array init. Let me just do, so we have the len and items, kind of. We have to swap dup, so we have len, then I would put pointer size of, so we have the size, and rot 4, so we get the items at the end. And now I can do array.init, and we need a 0, 4, so this is the array. For I, which honestly I'm gonna start from 1, as I said. We're gonna start from 1. Then I need a file name, which is gonna be empty string, and false, we're gonna do stack args.init, so we initialize the stack args from this, and then we can call to, so now we have the args as well, so we can call to stack args.parse, and maybe a function stack args init empty is gonna be much better. So it's like false stack args init. Right, so we don't have to put all of this stuff here because it looks weird. So empty. And yeah, then we can start to parse. So we got to this point, right? We get the argv. So then we can dupe. Hopefully this is gonna work. We can dupe that thing. So we get argv twice. We get a len. We swap, and then we get the string. Right. A quick question would be, what would happen if I just do this? So we get args array I, so here is like a to do parse. So we get I, then we just need to do I plus 1. So I plus 1, we have args array, so we just need to rotate and bring args first, and then call to dump or whatever. So if I run this example, bulls, oh, args dump, it's stack args dot parse prime, and this thing returns stack args, or like args. What do you mean by bool size of is not defined? $28. Wait, what? I guess it makes sense because it's external data type, so it doesn't have a size of. Same as integer. Totally forgot about that. So it's gonna have int size. Okay, so it continues to print stuff. So if we change this thing into help, we should see help. But we also see, wait. Shit. So this one, parse pop. Oh my god, segfault incoming, I guess. Segfault fucking incoming. Whoa, it's working. Holy moly. Let me just comment this out. Oh. And this is why I have undo 3. Because sometimes you need to, like undo and redo aren't enough. Sometimes you redo over an undo, so it's gone. Anyway, so at this point, we have a string. And we want to work with this string. So let's dupe string, and then let's check if it's equal to help. String.equal. And if this thing is true, then we have args array I string. And in the end, we want to obtain args array I. So if it's equal to, we want to pop the string and stack args.usage. Yeah, stack args.usage. Maybe it doesn't also exit. Maybe we decide to exit here. 0sys exit. Because maybe we want to exit with an error. So now if we run this thing, what? Oh, here I need to pop. So we get the usage. Nice. So here I should maybe do a new line, string.std out. Options. So main help is like that. We have the help message, so let's copy this one for our usage. String.std out. I think it's something like this, right? I mean, it doesn't matter, it's just my OCD std out. So at least we get the help message. So I would also add the input file. So that's important to also add the input file, string.std out. std out nearly. All right, so this looks good. All right, so we have the, I mean, input file should be a bit more to the, yeah, like that. Right, looks better. I mean, I know I have some new lines in between them. I can just add those like this. Right, it looks more like I mean, yeah, whatever, without this one and with another one here. So this one looks like this and this one looks similar. Well, let's not print the status code anymore because we don't need it. So it kind of looks similar. Anyway, let's see now. So what is our next case? We do lexer string equals if we have the same stuff, else we need to add a fee. So if we are on the, if we found lexer, we need to set the lexer to true in our arguments. Right, so how can we do that? We have a function for that, and we need to do something like, so it's a function that takes in stack args and the boolean, and it's called stack args lexer.set. So it's the field name plus set at the end. It's automatically generated. So that means we have to rot 4 to bring the args forward, because right now we have like args array I string. So we bring the args forward, we add a true, and then we call this thing. And I'll be honest with you, I forgot if it's actually returning the thing. I don't think so. I think it's only, I think we need to dupe it. Right, so at the end we are left with args, so we can just rot 4 prime. So we push it back at the beginning. Right, and then pop the string. So that should be us building the lexer. So if we pass lexer, lexer should become true. Can I, okay, \n string.std. So we should see that now we have lexer is equal to true. Nice. Okay, and how about the file name? So how about the file? So for file name, we can either have null, which is indicated by empty string, or we can have like something. So on the else case, potentially. Right. But let's also do lowercase l. Lowercase l is the same thing, but maybe I could have done here a swap, dupe, lowercase l string dot equals rot or, right? That's the way to do it, I think. So this one, let's just see, array I string. So we duplicate, check if it's equal, it becomes a boolean. We swap, we dupe, we check if it's right, then we bring this one to the front with a rot, then we do the big boolean, and then yeah, should be good. String.std. So this should be shown if we use either of these, right? So here if I do ASD, it doesn't do anything. Nice. So it's the same thing for help as well. So swap dup dash h string dot equal rotor, right? Is the same construct. So now is the interesting part. On the else case, if we find something in a string, right, we only set it as the input if the input is already null, because if the input is not null, it means we got multiple files, and we don't want that. We only want one file, right? So that's what we are gonna do here. So at this point we have args, the array, I, and the string. So we are gonna bring args forward with rot4. We are gonna dup it. We are gonna take the file name from there. So here we basically brought args, we duplicated it, we get file name, and now like string.length, for instance, so we get the length, and if it's greater than 0, we have an error for the parsing of the arguments, else it's all good. So here we are gonna have array, I, string, and args, right? And we want to return args array I. So what are we gonna do on the error case? I'm gonna do a rot4 prime to push that thing back. Rot4 prime. We don't really need to pop the thing. I'm gonna say usage. So at this point we have args array I string. We stack args usage. The user, we show them the message. Then I should say got unexpected argument space or something, maybe like that character. Okay, then we have to swap string concat, so we still have the string. Then I want to put this thing and string concat, and then maybe string.std error, maybe got unexpected CLI argument. So now we remove the thing, and we can just sys.exit with 1. Right, and it's the same, basically it's the same stuff. Right, and on the else case, what I'm gonna do is dup just rot. So we have array I string args, and when we rot, we bring string forward, and I'm gonna say stack args dot file name dot set, so these things go away, and then I can just say rot prime to put args back at the front. So that should be it. So if I put this thing twice, it's gonna say got unexpected argument ASD. Nice. So it looks like it works, and we get the command line arguments. That's kind of cool. So we have this piece of code that we have to bring to our stack.sl file, and I'm gonna put them right here. So this is the stack args, file name bool lexer. We have the usage. Right now it's only like L lexer. I mean, let's see, main help. Let's just copy the description. Okay, and in example, I'm just gonna put back the args dump. So example is just arguments dumping. Okay, so we have the stack args usage. I know it's not as nice as the argument parser from ds.h, but it's a start. Right, so we have the file name bool lexer, we parse the arguments. So here we can finally say int pointer, so we have arg c and arg v. So we can just do stuff like stack args parse, we get the args, and now we can have stuff like let's say dupe. So we have args, we have the arguments twice. Let me just do that like this. Then we can say stack args dot file name, so we get the file name now, and in stdlib we have fopen. All right, we have a function for opening a file, so that's kind of useful. Okay, so let's say we dupe the file name because we want string length. Again, we want length. If this thing is 0, so if it's equal to 0, we just remove that, else p. So at the end of this, I kind of want args and a file descriptor. Right, so if it's equal to 0, then we want std out. Right, that's what we want. We want to pop and std out. If it's not 0, so here we have args and file name. If it's not 0, we want to have read mode and stdlib.fopen. stdlib.fopen. Alright, so we open the file in read mode, and we are gonna do the error check, which is just not if panic v. So we are gonna be left with args and file descriptor. Right, so this is gonna give us the file descriptor to read from, and then we can say read all. Right, we just read everything from this file descriptor, and we are gonna be left with string and boolean, so not if panic v. So this is gonna be args and a string. So instead of passing this thing like this, we can just stack lexer, let's say args, we still have args. I'm just gonna remove this part because we are using it, so we can just get it back. Then I'm gonna pop 2, and I mean, we'll do more logic when we get to it, but now it's where is my stack example? Okay, so weird. Okay, so in 0.5 we have this new function, string length, which I want to do add to data ptr because it's, you know, kind of useful. It's pretty good function, string length. Okay, and if we go back to stack, it was complaining about stdlib fopen. So if I run example, it should want to read from standard input, And if I do, let's say, tests 01 lexer 01 number is gonna parse that file, and that's pretty epic, not gonna lie. So let's go into makefile, and let's add a rule, or maybe let's just build the else slc executable also here. So we are gonna do something like main right, we run main on stack.sl with dash a. Then can I, oh, I'm just gonna print it into, I guess I can do dash o, right? Or I don't have, oh, I don't, I'm just printing. Okay, fair enough. So we are just gonna dump it into stack assembly. Well, I guess better name would be slc.asm. Then we fuzzon that thing, the slc assembly, and then we ld it. Right, we ld into slc stack length compiler, and that's gonna be our slc build. And for now we are just gonna cp main, right? But in the future we are gonna have only slc. So if I run make, we also have slc now. And if I run slc help, holy moly, like this one is the one implemented in stack itself, right? So that's the point. So if I run stack.sl, it's tokenizing itself. Holy shit. Do we have any illegals? Oh, I mean, I was scared for a second. It's just the name. String illegals. Okay. Doesn't look like we have illegals. Perfect. So it just tokenized itself. That's kind of cool. So let's go to Nix file. I'd like somehow this one to be, you can switch here which main to use, because right now we use the a weird, like just main, right? But I can switch to slc, and now if we run nix run, and let's only run the lexer without memcheck, because we cannot have a memcheck for that one. It managed to tokenize some stuff, but not everything. So maybe we can see why. Maybe we can see why it didn't work. So for example, for the lexer for 07.sl, what was wrong here? I assume it's a naming convention somehow. Wait, what? I guess dash L. So is boolean true? Oh, I printed boolean for if statements, I guess. Stack SL. So when I'm printing this stuff, and I do stack token kind map, I'm probably printing boolean for the ifs. Oh no. Then I just, when I was building the if, I left, yeah. Oh, I forgot to change all of them, what the fuck? Yeah, anyway, so now if we run again, it should just rebuild, right? Nice. So import is now working. So 12 import, it should print something like that. And if we run it with src, oh, it found import as a name. Okay, so it means I forgot to add the import here. So if it's import, then we have import. It means I forgot about the import. Okay, so that's kind of the last error, maybe. No, fuck, I guess it's at import. Okay, so this test should now pass. Nice. And we are left with string invalid. So I mean, I'm not sure why this doesn't work. Func fee. But it should be illegal. That's true. What? How did it get func and fee? Oh. Okay, I think I know why. It's maybe, let me just see, function. Doesn't make sense. I thought it's something to do with the error kinds. So probably when I build the errors here, I'm putting somehow this thing in the reverse order. So stack token init should take an error here, right? And the kind here. So it means I'm somehow putting them in the reverse order somehow. I don't know how though. So if I say that we found new line, let's the std out. Let's just print something when we find a new line. Right, so we found a new line. It means I'm doing something wrong here. So here we pop all of these. Then I put, so we have a something like this, position, illegal, empty string, error. Oh, I don't even need to rot. Or am I wrong with that? Token should have the kind first, value, position, error. So I should maybe, now before I add this thing, I should rot instead. Yeah. So somehow I'm putting this thing wrong here. So I was putting like the position as the kind or something like that. Okay, that's funny. So now we get illegal, and if we run the tests for the Lexer, we are Gucci. Now memcheck doesn't work for this thing, I think. I don't know how slc tests 01 01. Like I don't know how Valgrind would work on this thing. So yeah. Anyway, so we got basically the tokenizer complete for our language, and we are also able to have command line arguments, right? Right now we only have the Lexer done. We'll add, I mean, I'll probably add, I mean, it would be nice to add the parser at least the beginning to do it together, and then I'm gonna do it on my own. Then we have the assembler almost done, and we'll try to get this pipeline to work. So we'll try to get as little as possible for the parser and just plug in the existing assembler, because the assembler is, I think it's like almost done. So we'll try to do that, and then I'll just complete the parser on my own, so that's fine. And then maybe we'll see about type checking, because that's gonna take some time. It's just grinding basically, and also the preprocessor, that's kind of useful. So we'll see about those. But yeah, I mean, kind of cool. We added the command line arguments. Yeah, I didn't really go over how I did Elixir, but it was just, again, just grinding, just copy pasting from the C code and converting the code to stack. So that's kind of what it was, just trying to translate the code from C to stack, because it's, it's kind of similar, but the work method is a bit different. So yeah, that concludes it for today. Hopefully this was hopefully it was an interesting topic of how are the command line arguments stored right in a program. They are basically on the stack, like what I found in the beginning with GDB. So that was maybe a thing that you learned today. So yeah, thank you for watching, and we'll see next time.